Hello and welcome to today's European SharePoint Office 365 and Azure Community webinar. My name is Shane and I'm delighted to be joined by Donovan Brown and Mark Fussell from Microsoft USA, who will be talking to you today about Microservices Made Easy, getting started with DAPR. Remember to join the conversation about today's webinar on Twitter. Our Twitter handle is @EuropeanSP and our hashtag is ESPC21. Don't forget to check out the Resource Center. This is updated daily with the latest blogs, ebooks, webinars, and how-to videos. Simply visit SharePointEurope.com and click the content link at the top. Welcome to Azure Week, one unmissable week of free online Microsoft Azure learning. For full details, see SharePointEurope.com/Azure-week. After the webinar, we will have a questions and answers session. Type any questions you have in the questions window. Questions will be selected and answered at the end of the presentation. This webinar will be recorded and added to the Resource Center, where you will be notified by email when it is available. And now I'm going to pass you over to our webinar presenter, Mark Fussell and Donovan Brown. Hello, Mark. Oh, if you just unmute yourself there, Mark. Okay, Mark, we can't hear you. Donovan, can you hear Mark?
I can hear you, but I can't hear Mark.
Okay, so Mark, if we can just get you, maybe your audio unmuted, we'll get cracking.
We tested this, we promise.
It's always with live, these things happen. So while we're here, Donovan, while Mark is,
Yes,
brilliant. Take it away, Mark.
Okay, all right, I'll just take off those headphones. Okay, well, thank you for having us. It's fantastic to be here, me, Mark, and Donovan. And today we're going to take you through and talk to you about DAPR, the Distributed Application Runtime. The way that we look at the world today is that we see that there are a lot of enterprise developers who are trying to build these distributed scalable apps. The types of things they're trying to build today are sort of services that are built around resiliency, scale, the requirements where you often have to take some existing code that you have and you want to be able to host it and run it inside the cloud. We see this because you need it to do efficiency reasons. We see it because a lot of the time you want to be able to reach a larger audience. And so often the type of apps that we see built are ones that are built around these microservices architectures. And that's because, you know, when you have this decoupled microservices architecture, it allows you to build independent pieces of code. It allows teams to be able to scale. It allows you to be able to version and upgrade different pieces of your application. But of course, you know, developers want to focus on building applications and not infrastructure. And want to be able to do this because your time is limited. You need to be able to get quickly to the business solution, not build the infrastructure solution. And so we see a general trend that developers like to build on existing PaaS platforms. Certainly there's a trend towards a serverless platform where you have to not worry about any of the infrastructure. And we also see a trend where developers are starting to use the tools of their choice, the ones that make them be most effective in terms of how they build their applications, which means multiple languages, multiple different types of frameworks. The issue is, though, however, is that it's not easy being a developer to build these sort of applications. In fact, it's incredibly hard. You're given infrastructure platforms, things like Kubernetes and other distributed systems platforms, but you're not given much help as a developer of how to achieve this. So the types of tools and runtimes are very limited about how to build these application types. Often the runtimes that you do have may have limited language support, or they have a tightly controlled feature set, and you're there waiting on some features to be developed by a particular framework provider or a particular company. And then often these runtimes are only targeted on particular types of platforms. They'll only run in the cloud, they'll only run on the edge, they'll only run on, sort of, say, Kubernetes as a platform, and they can't be portable and make your code around. So when we looked at these problems that developers had, where you had to be very efficient about building your business applications, you wanted to get up and running fast, we decided that we wanted to help you. So if you looked at a classic application, something like an e-commerce application like this, one where you have a front-end website. You may have a cart that stores some session data, or cart data. It's a stateful long-running service. You may talk to other systems like an email system or a payment system and communicate to other back-end services like queuing services or state store. This is a sort of application that you're trying to build today. Is a modern architecture that allows you to do scaling and versioning and resiliency around this all. So how could we help you as developers achieve this? Well, that's how we came up with DAPR, or the Distributed Application Runtime, that allows it for you to be able to easily build these portable, event-driven applications that run on the cloud and the edge. And today we're going to walk through that. We're going to talk to you about the capabilities it has. We're going to show you some great demos. And hopefully at the end of this, you'll have an appreciation about how you can go away and use DAPR inside your applications to build scalable, distributed applications much, much quicker than you could before on top of whatever platform is of your choice. So DAPR's goals really are, rather than you reading lots and lots of documentation about how to build these applications and then trying to figure out how to write your code yourself, we give it to you in codified best practice building blocks that you can use. And this is the key. DAPR has taken all the experience of years and years and years of how we've built distributed systems, and we've given them to you in API definitions in building blocks that you can pick and choose to use. You can choose 1, 2, 3, you can use whatever you want. And you can come at these with the tools of your choice today. A super important thing about DAPR is that you can come up with a language of your choice, the framework of your choice. You can just pick up the building block and just use it inside your code. You don't have to throw away all your code and start to learn a whole new framework. You can come at it by using the consistent portable APIs that DAPR provides for its building blocks with the languages and frameworks that you use today. And we adopt standards wherever we can. Things like HTTP, gRPC. For tracing, we use OpenTelemetry. For identity, we use a standard called SPIFFE. Most importantly, and you'll see this in the demos, is we make DAPR extensible and pluggable. So you can actually build it on one system and move it to another and simply change out components for the type of application you're trying to build and make your code portable between whether you're developing it on the edge, running it in the cloud, or actually even moving it between the clouds. And finally, one of the most important things about DAPR is it's community-driven, vendor-neutral. I'll show you the great community impact that we've had, later on in this talk. But suffice to say that since we released DAPR a year and a half ago, we have a huge surge of the community developing, contributing, and building code that they've contributed back to the open source repo that we have. So let's start to dive into DAPR and kind of get into the details and appreciate actually what it is. So at the heart of DAPR, we have a set of DAPR's building blocks. And these building blocks, you can see here, service-to-service invocation, state management, publish and subscribe, bindings, actors, observability, secrets, are all exposed through HTTP and gRPC kind of interfaces that you can talk to. These are the standard protocols for talking to these building blocks. And then you can cover it with any language of your choice, whether that's Go, Node, Python, .NET, C#, and be able to talk to these particular building blocks that you can now use in your code. What's more, you can directly talk them over HTTP or gRPC, which is one of the easiest ways, but we also do provide a set of SDKs that give you powerful language or SDK specific frameworks if you want to use that as your choice. And then DAPR itself can be hosted on any infrastructure. You can run it on Kubernetes, you can run it on a set of VMs, other platforms are slowly being introduced. And then of course, you can actually move this between your cloud of your choice, whether you want to run it on Azure, whether you want to run AWS or Google or one of the other public clouds. So the portability between cloud and edge and the pluggability with these different building blocks makes you be able to take advantage of DAPR's capabilities to be able to build these applications. Now, the second key to DAPR is how it gives you these capabilities. In order to take advantage of DAPR, we use what's called a sidecar model, which is sort of the modern equivalent in the networking world of building a DLL. So here's your application, and when you launch your application, DAPR runs as a sidecar. That means all the communication that you do is over a local network communication over HTTP or gRPC to DAPR, and DAPR then offloads does all the hard work on behalf of you for whatever API you're calling. So the DAPR sidecar runs next to your process. The advantage here, think of it a bit like a butler to your application. It's doing all the hard work, it's helping you serve all those requests, and you simply write your code and run it inside your application. So now for you as a developer, all you simply have to do is learn APIs that you want to call. And you have to simply call a local host API on a particular port that you've set up that you've known for your DAPR instance. So in this particular case, I'm using the invoke capability of DAPR, which allows me to call another service and be able to call another method on another service anywhere where it's running inside my environment. So in this particular case, I'm calling the new order method that's on the cart service that's running somewhere inside my environment. I don't know where it is for my application. DAPR takes care of the discoverability, finding out how to call that particular new order method. It does security, does it securely in terms of encryption on the wire, and ACLs to the actual endpoint itself. It takes care of retries. It takes care of an event of this particular cart fails and moves to another machine. All of that's taken care of for me. I simply just do a local host call in order for me to call this method. And as we go through the rest of this presentation, you'll see that there's a similar method that we have inside DAPR on the sidecar. In order to save some state and retrieve a particular item I've stored, number item 67, I can use a state API. In order to publish an event to a shipping service that's running somewhere inside my environment, which is listening on the orders topic, I can just say publish this orders topic to whoever's listening to this. And then finally, if I want to get hold of things like secrets, if I want to get hold of a particular password from my key vault, I can use a secrets API. And so this capability empowers you as a developer now to build these scalable, distributed, decoupled applications simply by doing local host calls like this. When you put this together in an application and you have more than one service, in this case, I have service A and I have service B, here each service, each application and its service gets their own instance of the DAPR sidecar. So service A has a DAPR sidecar instance, service B has a DAPR sidecar instance, and now when I want to call from service A and take advantage of calling securely between the applications, DAPR will take that call, it will discover where service B is, and it will actually call on behalf of service A onto service B for you. So DAPR takes care of all of that discoverability, security, and failover and retry for you. Now, importantly, DAPR also has this pluggability model with the components that I mentioned. So now, if I want to take advantage of DAPR state stores, where I want to store state inside one of the state databases, because I want to, for example, make a stateful shopping cart or a long-running gaming service, or I want to store the state of a workflow that I studied because I'm building a workflow state application. I can store that state in any database of my choice through the component model. So once I write my code and I store my state, say, inside Cosmos DB, if I want to change my mind and move it to Cassandra or to one even on a completely different cloud, say AWS DynamoDB, I can simply switch out the component that I choose and not change any of my code. This makes DAPR very powerful now for doing things like local development. And then if I want to move my application to the cloud, I simply switch out the components that I'm using without changing any of my code. So this is a complete application. You see DAPR with its sidecars, DAPR with its component model. We're going to now spend a little bit of time diving into each one of these building blocks, talk about what the capabilities are, and then we'll do some demos on the way to kind of show you how they work in action. So as I mentioned before, we have things like service invocation, state management. Let's start off with a couple of those first to talk about exactly how they work and how you take advantage of them. So let's start off with service invocation. What is service invocation? Service invocation is where I have two services and I want to be able to call a method on it remotely. It's just like RPC call. Here I am on my machine. I want to call a particular method that's running on another machine somewhere in my environment. I don't know if it's the same machine. I don't know if it's a different machine. I just want to be able to call that endpoint. So here I am in my code. I do my local host call to my new order method on service A, and I give it some data. I say, hello world. DAPR takes advantage of discovering where that is. There's a pluggable component that does this name resolution. So, again, this is taken care of for you. This is just part of the environment you run things in, whether you're running on, say, Kubernetes or running on a set of VMs. And then it makes it encrypted on the wire and calls on behalf of you into service A, the new order method, and it provides it that data called hello world. And then the return path is it simply gives you the callback. So all I had to simply do was this local host call, and DAPR took care of all the rest of the call and all the complexities around all that. Equally, as I'm doing all of these calls, one of the most wonderful benefits about DAPR is that because all these calls are going through DAPR, it can gather all the telemetry and the metrics and the logging information on my behalf. And it can push all of that into a monitoring tool of your choice. So out of the box, by using DAPR for free into any monitoring tool of your choice, you can push in all of the telemetry data and see things like call log times, call graphs, build up the visualization of all of this. And what's more is that not only does it for things like service invocation, but in the other building blocks where I do publish and subscribe methods, DAPR takes care of putting a W3C tracing context header in the messages, whether that's in the direct calls or in the publish and subscribe messages, so it can trace all these calls and push all that information for you and take it and gather all the metrics on your behalf. So that means now that I can also take advantage of not only direct calls, but I can plug in things like OpenTelemetry. And OpenTelemetry is an open standard that allows you to gather all that information and again, push it into a tool of your choice. So you have a couple of choices about whether you directly talk to a tool or take advantage of OpenTelemetry's collector in between to do this, which is becoming this is a CNCF standard inside the cloud native world. So when you look at the capabilities that you get, DAPR then allows you to do these call graphs, allows you to do these different, how often you sample, allows you to plug in a tool of your choice. And so I would be able to say, for instance, App Insights build a visualization like this that shows you all the calls between my different applications here. You can see here calls that show the number of calls I've made, the average time of these. In this particular case, it's an App Insights view, but I can plug in a completely different tool, in this case, Zipkin, and get the same view and the same sort of data of my choice. So out of the box, distributed tracing you get for free. So with that, I'm going to hand it over to Donovan, and he's going to give you a great demo of what I talked about so far.
Perfect. So we're going to switch over to my desktop here. So let me start sharing this for you. Perfect. And you should be seeing now basically the DAPR Docs website. So I wanted to bring you here so that you know exactly where you can go to get started. We have SDKs for several different languages. So if you want to use these SDKs, you're definitely able to use those. If you click on getting started here, it's going to take you to a place where you can actually see exactly how to install our CLI, which is the first thing you're going to want to do. You can install the CLI on Linux, Windows, or Mac. So whatever machine you're using for development, that's the right machine for you to be using right now. And we'll be able to initialize DAPR for you, and you'll be off to the races with your development. What I'm going to do is I'm going to switch over here into Visual Studio Code and just show that I am sitting inside of an empty folder right now. And what I'm going to do is show you just how quickly you can start to add some of this functionality. So what I'm going to do is I'm going to do a .NET new web API. So what I'm creating is a brand new out-of-the-box hello world type of application. And what's really cool is you can DAPRize an application without changing a single line of code. So what I'm going to do is I'm actually going to run this application, but I'm going to use DAPR to run it. So I'm saying, hey, DAPR, run an app and name it my app. I want you to run it on port 5000, and I want you as DAPR to be running on port 3500, which you'll notice matches some of the URLs that Mark was showing you in the slides. What's really cool about this is my app starts up, as you can see down here at the bottom, and I get logging not only from my app, as you can see here at the top where it says app, but also down here I'm getting detailed logging from actual DAPR itself. If I jump back over to my web browser, I'm going to come here, and this URL says localhost 5000, which is the port that you would normally access this website on. So if you already had an existing web service, all your existing clients will continue to work because the original URL is still exposed and accessible if you need to. But the power comes in when you use this tab. Here, I'm actually targeting localhost 3500. This is saying, hey, DAPR, I want you to go do something for me. I don't know the port of this other application. I don't know where it exists on our network. I don't even know how many instances of that other application there are, but I know the name of it is my app. And I want you to go invoke a method on it called weather forecast. So when I click on this, what happens is I get the exact same results. I'm still getting the exact same information I was getting before, but now this URL is portable. I can use this URL throughout my application. I can completely change the other service, the ports, the number of instances, where it's located, but my application does not have to change. I address localhost 3500, go call this particular app for me, and magic starts to happen. So this is great service-to-service invocation handled for you automatically by just knowing the name of the service that you want to call. More stuff is happening in the background. As Mark mentioned a second ago, Zipkin is also running. And if I run a query here, we can see just a few seconds ago, I made a call. You would not get this out of the box when you just do a .NET new. To get this information, all I had to do is say, hey, DAPR, I want you to run my application and monitor it for me and let me know every single time something gets called. And not only that, it lets me know how long that actual call took, what the status of that call was. And this information here, I can start to use to diagnose, maybe I have a bottleneck somewhere in my application. And I didn't have to add any code. I didn't have to write any telemetry. I didn't have to take the dependency on a library. I simply said, hey, DAPR, go run my app for me. And while you're doing that, collect all this great observability information for me and also handle service to service invocation. So with just running the app that I have not changed at all, I'm already starting to be able to use some of those building blocks that Mark showed you a moment ago. I was able to use observability, which I'll show you here, and I was able to use service to service invocation by not changing the app at all. So what I want to do now is I want to turn it back over to Mark and let Mark show you some of the other building blocks, and then I'll show you how easily we can add those building blocks to this Hello World application.
Okay, thank you, Donovan. That's a fantastic demo. Before I dive into some of the building blocks, I want to give you some appreciation of what's happened in the community since we released DAPR. So DAPR first got released in October 2019, and since then we've had a huge number of community contributions that have come to help us kind of enhance DAPR and provide inputs to not only building the actual source code itself, but actually how we built up the community itself. So if you go to our repo, you'll see that there's a large number of contributors that can contribute to it. Over today, we've had over 1,000 contributors who've contributed both to the documentation, to the code, to building the components. When we first released DAPR, we only had about 5 or 6 components. So the vast majority of those components that you'll see have been built by the community. We do a regular community call, which we'd love you to come and invite you to and come and listen in, and we do lots of fun demos. You can go to the Discord channel where we have over 2,000 members, and then we get lots and lots of people who come and visit our documentation and see kind of how to build their applications themselves. Yeah, a number of different companies have contributed towards this, including VMware, Intel, Alibaba Cloud, and this is just part of the list of some of the growing number of different organizations that have made DAPR, you know, a platform itself that can be used across many of their different types of organizations. And then earlier this year, we actually took DAPR and we submitted it to the Cloud Native Computing Foundation. So we're trying to make sure that DAPR lands in an organization body. So that way, you know, there's no one vendor control, and that DAPR can be contributed to by the whole community itself. The companies that have run into in production today are companies like Zeiss that built a workflow ordering system where they do worldwide global orders across lens manufacturing that they do across the world, or Alibaba Cloud has integrated the DAPR deeply into their actual platform itself for how they host and run their infrastructure. You can go to our adopters.md file down below here and see some of the other companies that are taking DAPR into production and read about their stories. So returning to the building blocks and talking about them a little bit more. So let's talk about state management. So what is state management? State management is when you want to make a service long running and stateful, which is very, very common. So for example, you might have a shopping cart that you're storing some state in, or you might have built sort of a workflow engine where you're saving the workflow state. We're saying, do this order, do that order, keep hold of the state, and then recover that, you know, in the event of failure, you know, pull back my workflow state and keep running from where I last left off. So state management is about making stateful, long running services that you can keep the state in and recover it in the event of failure. And in this particular way, you can take advantage of DAPR running as a sidecar and take advantage of one of the pluggable components that you plug in there. For example, in this particular case, I'm taking advantage of Redis as a way that I can store my state information. So here, I can set up a named particular state store called corpdb. And now I can take advantage of the state API to call onto corpdb. And all I have to do is give it key value pairs. So the key value data, in this particular case, is called key value of weapon and the value of Death Star. It's stored into my state store of my choice. Now, the key here now is that I can actually now pull that data back out. I can go in and say, I want to pull back out that particular key with the same API call again, and I get my data back out. But the next thing I can do, of course, is I can simply switch out the same component for another component. I just keep the same name of my choice, in this case CorpDB, but I switch it out for a completely new state store of my choice. In this case, I've switched it for Cosmos DB. But in this way, my code that I showed you before, where I'm calling onto my state store to store my state, doesn't change. So this is very, very powerful now. So I can do things like develop an application locally and then take advantage of switching my application to a different type of state store when it runs inside the cloud, giving you that code portability. Or I may be not too sure on the type of state store I want to choose early on, and I get the flexibility of later design choices about how I move my code, only because I didn't have to pull in a whole set of SDKs or actually even learn SDKs for some of these things. So this premise of this component pluggability makes DAPR very powerful. And as we go on, you'll see that it makes it much easier for you as a developer to do particular capabilities, because you don't necessarily have to learn about all of the particular SDKs to do those things. In a similar vein, let's talk about publish and subscribe. Publish and subscribe is a very common mechanism now of how you send events from your service to other services, because you want to tell them about things that have happened. This is an event-driven architecture. And event-driven architectures allow you to have decoupled systems. You send messages, you just act on those messages, and your code just simply receives messages and decides to do things. So for example, you might say, I've now published this order, and I want to tell a number of other different services that an order has been published, and that they can now take action. They can maybe send a request off to someone else that they can go and see the status of their order, or they can actually maybe go and view their order through some UI. So again, in this world, DAPR runs as a sidecar. I can choose the type of way I want to send my messages. In this case, I can choose Redis again as a way of sending messages through a publish and subscribe system. And now I can take advantage of doing a local call again. In this case, I can use the publish API to publish a particular message on a topic called order. And in that, I send my data called my order data. And then in this case, service A and service B decide to subscribe to those particular types of topics. So they simply say, we're going to subscribe on particular endpoints to the order topic that gets sent. Now you'll see in both these cases, they can say, when the message gets sent, I will subscribe so it gets sent to this particular endpoint on me. This is where the messages get sent. So now when my application publishes the order method, these particular services, A and B, will both get their own copy of the published message, which is sent to them, and the data it contains, my order, is delivered to them, and they can take action on that. Now, importantly, you can, again, as you saw inside the database world, I can have my Redis cache inside here, and I can have it so that I have my orders sent to my different services. But now I can switch out, and I can take advantage of the rich number of different types of pub sub mechanisms of components that DAPR is plugged in. So you can switch out Redis cache, say, for Azure Service Bus, or for GCP pub sub, or for AWS Simple Notification Service, or the NAT service, which is a very commonly used pub sub broker between services. So this allows you to take advantage of the pub sub capabilities, but choose a component of your choice. Equally, it's very, very common for my application to have events sent to it, so it triggers my code from external systems. In DAPR world, we call these triggers or input bindings that can that allow you to trigger your application. And there's a wide variety of these that you can choose. So for example, one of the input binding triggers that we have is one for Twitter, where you can say, I can hook it up to Twitter, I can give it a query that I want to see. When that query is satisfied, say, for example, I want to see all the tweets from a particular account or from a contain a particular keyword, I want you to send me an event notification about something that's happened on that particular Twitter feed. So taking advantage of the Twitter component that you hook up to DAPR, DAPR now can be set up so that with a particular tweet that gets posted, your particular endpoint, so in my case, in my application here, I have an endpoint here called new tweet, will be sent a message anytime the Twitter query is executed, and the data that it contains will be sent to your application. Equally, you can also do output bindings where you want your code to trigger an output system. Now, this is also sort of very common when you want to send something onto a queue to go off to another system, or you want to send something into another database for it to trigger. Or in this particular case, we have a binding to Twilio, which is a messaging communication platform. So I want to send Twilio to send a simple an SMS message, or I want to send an email on my behalf. So this allows you through the Twilio component to take advantage of, say, I want you to send off to the Twilio component, say, an SMS message, with the content "Hello World" to the phone provider I hooked up to my Twilio endpoint. So these input and output bindings allow you to communicate to external systems and triggers. It's very easy to build these things. This is where the community has been building lots of different types of component connections for these bindings that allow you to have DAPR be able to engage with external systems. So as you see here at the top, we have bindings for things like AWS storage, Azure storage, Twilio, Kafka. There's a wide variety of them. Now, the final building block that I think is one of the most key that makes a developer's life fantastically easy is the secrets building block. Time and time again, we've come across cases where you simply want to get hold of a secret out of a secret store and use that to authenticate against another service or another system. So, for example, one of the most common ones is I have to get some secrets out for a database connection string that I want to be able to talk about to talk to this particular database. Now, what often we see is that someone has to write a whole bunch of code that they actually build a thing like DAPR on itself to retrieve all those on their behalf, or the developer has to bring in the SDK that they want to use for a particular secret store that they're going to use just to get hold of a secret in order to talk to that database, in order to get hold of the connection string. DAPR makes this secrets management super easy. In this particular case, by taking advantage of the secrets API, I can say, go to my secret store, whatever I can set that up as. In this particular case, I took advantage of the HashiCorp Vault, but this could also be Azure Key Vault. It could be AWS's Key Vault and Secret Store. It could be GCP's Secret Store as well. And so I can set up a secret store of my choice by simply annotating it with a component of my choice. And I can say, for my vault, go and get hold of my secret through the secrets API that DAPRs provide to get back the super secret in this case, which is stored for the key name my secret. So combining secrets management in order with things like talking to state is a very powerful way for you to say, I can easily get hold of a secret to talk to my state endpoint, or whatever secret that you were trying to do. Say you're talking to some external system, you needed to provide a secret to that Twilio endpoint, you can get hold of the secrets all stored inside a single place. And again, just like the other APIs you saw, this My Vault is pluggable to other different types of secret stores. So to give an appreciation of these components, you have these different types of bindings you have state stores, you have pub sub, you have secret stores, you have observability, and you can swap out all these different types of components for the ones of your choice against all the different endpoints that you're using, whether you're choosing to use just one endpoint and one API for DAPR, or whether you're choosing to use more than one of these. The choice and the flexibility is all up to you. So this makes DAPR very powerful in terms of how it's able to take advantage of the simplicity of you just understanding a simple URL, but at the same time, the richness of an environment where you can take advantage of all these different types of components to communicate and swap out the different types of environments or systems that you want to be able to talk to. So with that, I'm going to hand it back to Donovan again, and he's give you a great demo now of some more of the DAPR APIs.
Perfect. So let me go ahead and share my screen again. Perfect. So we are going to pick up right where we left off. All I've done since Mark was talking was stop the application that was running before, and now we're actually going to start using some of the other building blocks. To do that, I am going to add a package to my .NET application. Again, I haven't touched the code at all. I've just added a package to this that's going to allow us to start taking advantage of DAPR. What I'm going to do now is I'm going to go ahead and open a file, the startup.cs file, and I'm going to start adding some power to this application using the DAPR SDK. So I'm going to go ahead and create an add DAPR call. What this is doing is it's registering the DAPR client so that I can use it with service discovery. So I can do dependency injection. So what I'll be able to do is I'll be able to inject the DAPR client into different methods simply by adding it to the signature of the method, which is really great. We also talked about having event-driven applications, and we want to be able to do things like pub sub. So what I'm going to do here is I'm going to add an endpoint mapping that does map subscriber handler. And then I'm also going to use cloud events. This is going to allow my application to now be able to turn into an event-driven stateful web service, responding to events from queues, being able to store state places, and use all the other building blocks that Mark told us. So I only added 3 lines of code to the Hello World application so far to start to light up some of this functionality. What I want to do now is I want to go into the controller class here and start modifying this particular controller. Out of the box, this application by default simply returns a random set of weather information. What I want to do is add new functionality to this application using DAPR that will allow us to actually take a post request when someone stores information into a queue. So I'm assuming someone's going to fire an event saying, hey, I have weather for you. When that event hits that particular queue, I want it to automatically come into my application as an event. So what I'm going to do is I'm going to create a new post event, and I'm going to go ahead and make it async. I don't need a custom route. I want it to go ahead and use the existing weather forecast class. So this is nice to be able to add this value without modifying the contracts that I currently have. And I'm just going to go ahead and return the model from here. So how do I make sure that this method is called every single time an event is published to a particular topic? All I have to do is add an attribute that says, hey, DAPR, I want you to create a topic that listens for the pub/sub component on the new topic. If you're wondering where I got pub/sub from, I'm going to go ahead and open up this folder here. This file has a component in it named pub/sub that was configured for me automatically when I ran DAPR init. I'll be able to change this out, which I'll show you just in a moment, but I will not be changing the name of the component, just where it points. Right now, it points at Redis. You'll also notice that it has another one here that's called state store, which I'll be using in a moment, that also currently points at Redis. If I want to change where these points, I simply change this YAML file, redeploy my application without changing a single line of my code, and I can target things that are in Azure or AWS or somewhere else in the world. So what I'm going to do now is this is where I got the word pub/sub from. I also need a DAPR client, and because I did the add DAPR, I can now do things like this, which it says I want to inject a DAPR client into this method. I'm going to take the model that we get, and I'm going to update the date to equal datetime.now UTC time, and I'm going to store this model into the state store that's configured with DAPR using the DAPR client. I'm going to say save state. The type is weather forecast, and I need to pass it the state store. Remember, I showed you the name of the state store. We're going to go ahead and store this in something called weather, and all I need to pass it is the model I want to store. So now with that one line of code, I have now been able to take that model and store it inside of our state store. What I'm going to do is I'm going to change the get method to go read the weather from that state store. So what I'm going to do here is I'm simply going to come down and I'm going to remove this code and change it. But notice I'm not changing the signature of this code. I'm going to get rid of this. And remember, I'm going to need a DAPR client, and I'm going to return a new list of weather forecasts. And I'm going to initialize this using the DAPR client, where I call get state async of type weather forecast like we did before. I pass it the name of the state store, and I pass it that I want to get it from weather. Because this is not an async method, I'm just going to go ahead and grab the result and put a semicolon here. So this is great. I've added a few lines of code, and I've now completely added new functionality. You can now store a weather element into a state store that's provided to us automatically by the event that's posted to the new topic of a pub/sub. The first time I ran DAPR, you saw me drop to the command line and I did a DAPR run command, but I don't want to have to remember all those different commands for the command line, and I want a nice rich F5 experience. So when I press F5, the sidecar is already started up, my application is fired up, and I can hit these breakpoints. To do that, the first thing I need to do is tell .NET, hey, generate all the stuff that I need to have debugging enabled. Then I'm going to go back and I'm going to use this thing called the DAPR extension that has scaffold DAPR task. It's going to go ahead and use my launch configuration that was created for me. I'm going to call this my app, and it's going to run on port 5000. What happened was, if you come over here, we now have this new configuration that says with DAPR. What DAPR did is it figured out the app I wanted to start and how to start it up for me. So let me show you what this did for us. It created a pre-launch task that has a DAPR debug that it wires up for us. And it also created a post-debug task that tears DAPR down and starts it up with our app. We don't need this section here. All this section does is starts a web browser, but we're actually doing a microservice that doesn't need a web browser for us to actually access. With that set up, what I can do now is save this file and press F5 on my keyboard, and now I'm starting a debug session, which means I should be able to hit these breakpoints and debug my application, even though it's running what's inside of DAPR with the sidecar running, and everything gets wired up for me automatically, which is happening down here in our output. Now that the application is running, I'm going to go ahead and exercise this using an extension for a DAPR, for Visual Studio Code that allows me to execute HTTP requests. I happen to have a sample file that has some HTTP requests in it. The first one points at localhost 3500, just like Mark showed you before. And I'm basically saying I want to publish onto the pub sub component into the new topic, this object itself. So if I go ahead and send this request, a couple things happen. First, you see I hit my breakpoint, which is fantastic. I can now debug that my code actually receives the event, that the event looks the way that it's supposed to, that my dependency injection is working because I now have an actual proper DAPR client. And I'm going to go ahead and remove this breakpoint and hit F5. If I come back over here to my samples and I click get request, we now see we're in our get method. All the debugging is working great. I'm going to go ahead and remove this breakpoint now that I've hit it. Press F5. And over here on the right-hand side, you can now see that that item that I created has now been retrieved from the state store, proving that it was safely stored into the state store. Great F5 experience. About, what did I add? Half a dozen lines of code, and I now have an event-driven, stateful web service thanks to DAPR. Now, this is all running locally, but what happens when I want to run this into the cloud? I want to be able to use things like Service Bus or maybe the Azure storage. What you'll notice is I have two more components in a folder called Azure Components. Same state store, but now the state store is pointing at Azure. I also have PubSub. Same PubSub name as before, but this PubSub is now pointing at Service Bus. The way that I utilize these components is not by changing my code. What I'm going to do is I'm going to come over here. I'm going to go into the task file that was created for me by the DAPR extension. These are all the parameters that I would have to remember and type into the command line that the DAPR extension is doing for me. And what I want to do is override where it's reading my components from. I'm saying don't read the components from the default location, read them from my specific location. Now if I go ahead and press F5, it's wiring up everything, but now these components are actually pointing to resources that are in Azure, not running locally on my machine. And you can see here the component path is set to Azure Components, letting me know that it's reading those components from a new location. You can do this in your dev environment, your QA environment, and your prod environment throughout your pipeline. So these modifications to these components are really, really simple. What I'm going to do now is prove that we're pointing at somewhere new. If I were to try to go and do a get, I get nothing back because we're not pointing at Redis anymore. We're now pointing at an empty storage account. But if I come here and post the request again, then I can come back and do my request, and you'll notice that I am now reading that value from our storage. And I can prove that for you. But if I come back over here, here's my Azure subscription. Here's the storage account that I'm pointing to and the service bus. I can come into the storage account. I can click on Storage Explorer. And by expanding this, you'll see that there's a weather table in here. And there's the record that we just stored using DAPR. So moving from on-prem to the cloud is just changing your configurations, not changing your code, which is a really, really powerful concept. It gives me a great local F5 debug experience, and without changing any code, allow me to lift my code and put it into the cloud and start utilizing new different resources as well. So that was the last that was the second demo that I wanted to show you. And what I want to start talking to you now about, and I'll actually, since we're going to go to slides, I'll actually turn on my webcam for you as well. We're going to start talking about DAPR because it's an open source project and what Microsoft is doing from an open source perspective. Microsoft is the #1 contributor to open source in the world. Over 30,000 of the employees here at Microsoft have our identities for Microsoft associated to our GitHub accounts, just showing the volume of us that are actively in the open source community. We have over 60,000 unique open source components that we work on, and we use over 9.5 million. So we have a vested interest to make sure that the open source community is well looked after from a Microsoft perspective. Microsoft's contributions from open source span operating systems, cloud native development, data and AI, languages, and the web. We are all over the place because in Azure, we provide all this type of resources for you in the cloud. Over 50% of the cores running in Azure right now are running Linux. So we have a vested interest to make sure that Linux runs well and that all the components and open source components that you want to use also run well on Linux inside of Azure and inside of the cloud. One of the things I want to make sure people understand is because we're so invested in making sure that Linux runs well, all the original or existing open source components that you know and love, you can actually continue to use. We have the databases like MySQL, Postgre, and other type of databases that you're accustomed to using in the open source community are available for you. We have analytics and data that's already built in cognitive services that you can use from any language as well. Running open source successfully on Azure is paramount and crucial to our success, and we just want to make sure that you understand that we are heavily invested in making sure that open source and Linux in particular run really, really well on Microsoft. So what I want to do now is show you one last demo, and this demo is a Java application using the Open JDK distribution from Microsoft. And what we're going to do here is start using a few more of those components that Mark was telling you about. He showed you the Twitter binding, where we're going to use that inside this demo. And we're going to be able to set up an application using Java that registers using the input binding for Twitter and says, every time a tweet comes in with a certain criteria, I want you to call me. I'm then going to use that tweet and I'm going to send it over to another service that uses cognitive services in Azure to score the sentiment of that tweet to tell us if it's neutral, positive, or negative. We're going to then take that tweet and store it in storage for later processing, then also publish it to an event that will then be read by our front end that will then show those to the user. I like doing this demo in Java because it just shows that DAPR can be used anywhere. In the .NET application, I use the .NET SDK, but in this one, I don't use any SDK at all because you're not required to use it. And if you're already comfortable with your HTTP client of choice, you can continue to use that and still leverage all the power of DAPR. So let me go ahead and hide my camera so that we can go ahead and fire up this demo.
Mark, your audio is on, or sorry, Donovan, your audio is on mute, so we can't hear you.
Sorry, let me go back and I'll start this over again for you so that you guys can, if you prefer using, get me back here. One of the cool things about DAPR is you can use it with any language, even languages that haven't been invented yet. If your language of choice can make an HTTP or gRPC request, you can use DAPR. However, if you prefer using an SDK, they are available for many languages. I decided to write this application in Java using the Microsoft build of OpenJDK that is a drop-in replacement for any OpenJDK you might be already using. We also ported the OpenJDK to Windows on ARM and the new MacBook M1 devices. As a developer of this application, task number 1 is figuring out how to get tweets from Twitter. Thanks to DAPR, I did not have to learn the Twitter APIs or install any SDKs. I just defined a Twitter binding with a query, and when a tweet is sent that matches, our service gets called. I simply wrote a post method and DAPR delivered the tweets. On lines 39 through 44, I am setting the URLs to use the DAPR components. HTTP request to these URLs will allow me to call another service, store state, and publish events. When I'm running locally, I will be using Redis for my state store and PubSub. However, when I deploy to Azure, I will be using Azure Storage and Azure Service Bus. But notice, there is no need for Redis or Azure-specific code because I'm using DAPR. Here's an example of a service-to-service invocation. I am using the standard HTTP client class to issue a post request to DAPR. DAPR will find the other service on the network and call the desired method for me. The service on the other end just defines a method that accepts a post request to the same route. Services don't even have to know they're being DAPRized to reap the benefits. Services run with DAPR will get observability and tracing for free. Storing state or placing a message on a topic can all be accomplished by making an HTTP request to the correct endpoint. Let's run the application locally. I have already started the viewer and processor services. Now I'm going to run the provider using DAPR so it starts getting tweets. With DAPR streaming logs from all three services, I feel like a TV show hacker. Switching to my browser confirms that the third service is processing the tweets from the DAPR PubSub component. With my local testing complete, it's time to move the code to Azure. Because I'm using DAPR, I don't have to change a single line of my code. All I have to do is update the component configurations to point to Azure resources. The same is true if I move my code to another cloud or to the edge. I'm going to deploy my entire solution, including my infrastructure, using GitHub Actions. My infrastructure will be deployed using Bicep, which is a language that allows me to implement infrastructure as code. Infrastructure as code is a DevOps best practice where you codify your target infrastructure and automate its deployment. Using GitHub Actions, I can also codify my entire workflow using YAML and target macOS, Windows, and Linux. This is a GitHub Actions workflow that builds Docker images, deploys the infrastructure, and installs the application using a Helm chart into AKS. Because this workflow can be triggered every time a developer commits code to a repo, we can implement continuous integration, or CI. CI is the practice upon every commit the code is downloaded, compiled, tested, and packaged for deployment. Here in GitHub, picking a run will take us to the summary. Notice we build 3 Docker images and deploy infrastructure at the same time, drastically reducing the time to execute the workflow. You can review the individual steps and logs by selecting a job. For instance, here is a step that used the Azure CLI to deploy our infrastructure using Bicep. Examining the deployment job illustrates how flexible GitHub Actions can be. There is an entire marketplace with thousands of actions that you can use to build your workflows. If you don't find what you need, you can always create your own or run a custom script. For example, in the Get IP step, I was able to query the IP addresses of the services exposed by AKS using a PowerShell script. Clicking the first address will take you to the viewer now running in Azure, reading tweets from Azure Service Bus instead of Reddit. This is one example of how easy it is to move your code from your dev machine to the cloud without changing a single line of code. The second address allows us to review trace information automatically provided by DAPR using Zipkin. Here is a trace of a tweet entering the app from the Twitter input binding, being scored by the sentiment service, saved to the state store, and making its way to the viewer. This level of trace information is invaluable for troubleshooting microservices and is provided automatically when you DAPRize an application. Writing microservices no longer has to be scary. Combining the power of DAPR, GitHub Actions, and Azure enables anyone to build and run microservices at scale. After watching that demo, a lot of people ask me, why does Microsoft have its own build of the OpenJDK? And the reason is because we run a lot of Java here at Microsoft. We run over 500,000 JVMs here because of Minecraft, LinkedIn, and even some of the infrastructure that manages Azure is all written in Java. We want to be able to share our expertise at running enterprise-grade Java applications with the community. Not only do we use Java, but a lot of our customers use Java. And having our own build allows us to respond to their needs and our own needs very, very quickly, and also contribute upstream to the OpenJDK Java community as well. So if you're curious on why, that's why we have our own OpenJDK. Here are some more resources that you can use that will share our concepts and our thought process on open source here at Microsoft. And if you want to join specifically the DAPR community, I wanted to make sure that you know that there's an ebook inside of our docs that you can read on using DAPR with .NET applications. We have a Discord channel. A lot of us are hanging out on Stack Overflow and trying to make sure we are where our customers are and our users are. And we have a great community on GitHub. I remember when I first joined the team, I contributed a component to learn what DAPR was all about, and it was a fantastic experience. The team is very kind and very patient as you start to build up your confidence on submitting requests to DAPR. So that's the last slide we have. We have about 6 minutes left. So go ahead, if Shane, if we have any questions that Mark and I can answer, be more than happy to answer some of those questions for you.
Thanks for a great presentation. Yes, Donovan and Mark, now we will start the questions and answers part. And should you wish to ask a question, please type it into the questions window now. Okay, first question is what is the impact on performance from the sidecar?
Yeah, let me take that one. The performance, actually, we're fairly fanatical about the performance. And one of the crucial plays we measure it is when you do that service-to-service invocation, where you call from your application through a DAPR sidecar across the network to another DAPR sidecar to another instance of to the application instance and back again. And DAPR actually only adds 2 milliseconds to that whole end-to-end round trip that you have. So it's very, very lightweight and very, very performant. DAPR itself only takes about 30 megs of memory. And as I say, in a network where you send a 1K packet of data over a 100 gigabit link, 2 milliseconds is the additional overhead. So it's pretty minimal.
Okay, super. This is a long one, so please bear with me as I take a deep breath and get ready for this. Okay, I am having trouble setting up my project to run on my dev station using DAPR with Docker Compose. The DAPR documentation is lacking a bit on this approach. I've been unable to use the state store, and I think it's got to do with the network in the Docker Compose YAML. Can you show how this can be done?
Yes, I think one of the best places for a Docker Compose example is at the end of that last slide. Donovan pointed to a free ebook which was called .NET for DAPR applications. Even this is a .NET application. Actually, even then it doesn't matter. But inside there, there's a chapter on actually how you use Docker Compose and put it and use it to launch your application. So the best thing to do, actually, two things: read that book. And give it, there's an example inside there, and then post your question on the DAPR Discord channel, and just go to the general channel there and just say, here's my issue with the Docker Compose. Post your Docker Compose inside there, we can take a look at it. It's probably to do with the fact that you have to make sure that you launch your the Docker Compose, your applications all on the same Docker network. So you have to make sure that it's a network setting almost entirely between you making sure that your container and DAPR container in the Docker Compose file are all launched inside the same Docker network. So check your Docker network setting inside your Compose file. It's most likely to be that.
Yeah, and I would also look for Cecil Phillips. He's on Twitter and some other social media. He did a great demo at Build where he actually used Compose to fire up his application. So we definitely have some people who have done it successfully in our community and could help you get that going really, really quickly.
Cool. Okay, next question. I've always been told to keep containers stateless. So technically, although in the sidecar, is this ongoing against the recommendation? The state is still being managed elsewhere. Is this correct?
Yeah, that's correct.
The state's outside of your actual microservice. That way you can have 1,000 of them running, and it doesn't matter which one you re-enter to, right? That's the reason they don't want like sticky sessions or a state has to be stored external. Otherwise, you wouldn't be able to fan out or scale out your application because state would be tied to a particular instance. And now because state is actually offloaded into a separate component, then I can still have 1 million of these front end or 1 million of these services or 5 of these services, and that's fine. And we're not breaking that like I think it's one of the 12-factor rules. We're not breaking that because your state's not stored in the service itself.
Okay, and last question: can you run DAPR in an Azure web app to talk to another PaaS service, or does this need to run in Kubernetes? As you mentioned, it runs as a sidecar.
So you don't. I haven't done it in a web app, but you can definitely run DAPR outside of Kubernetes, right? As you noticed, when I was doing the F5 experience on my machine, I was not running inside Kubernetes. The actual application that loads the sidecar and does all the communication for us, you can run it on a VM, a bare VM. But Mark, have you run it inside of an actual web app or with the web app? I haven't.
Yeah, actually, this is more of a statement of can I run it on a web app that's running on Azure App Service,
right?
As that hosting platform. And the answer is right now, no, but that's certainly something we're looking towards to do. And we're certainly looking at how DAPR gets integrated into Azure services itself. So you can partially you can take advantage of some of the functionality. You can't take advantage of all the functionality of DAPR just yet. So, for example, you can run it in a web app, take advantage of the state storage and other capabilities, but some of the networking capabilities are not possible at the moment running in web apps as easily. But we're looking at how to do that. But so right now it's kind of running inside Kubernetes and instead of sort of VMs themselves. But watch this space, and we'll do some announcements hopefully soon.
Cool.
Super. Well, on behalf of the ESPC community, thank you, Donovan and Mark, for taking the time today to complete this webinar. We really appreciate it.
Our pleasure. Thank you.
Yeah, thank you for having us.
Great. This is the end of the webinar today, everybody. This is part of Azure Week, one unmissable week of free online Microsoft Azure learning. For full details, see sharepointeurope.com/Azure-week. This is the end of the webinar today. A big thank you again to Donovan and Mark. You will be able to find this webinar and more at sharepointeurope.com in the Resource Center. Thank you for joining us today. Take care and goodbye.